Hello everyone. Today we'll talk about the role of cloud-based simulation in development and testing of robot applications. AWS RoboMaker brings cloud scale to simulations. The technical benefits include the ability to run hundreds of concurrent simulations with the RoboMaker Batch API, fully managed AWS infrastructure, which enables you to run your simulations consistently and reliably. With by-the-minute pay-as-you-go pricing, you only pay for simulations when you're using them. You get the benefits of a managed service with ROS and Gazebo built in, which will free up engineering resources. Finally, the ease of integration with the breadth of AWS services enables you to connect your ROS application and tooling with services like Amazon CloudWatch Logs and AWS Code Pipeline. One of the key software validation best practices is regression testing with a continuous integration and continuous delivery, or CI/CD pipeline. AWS RoboMaker makes it easy to test your robot applications under many scenarios by running tens or hundreds of in-parallel parameterized simulations with a single API call. These tests can be triggered with every code commit in your CI pipeline or with nightly builds to reduce the number of software defects and ensure that your new code does not have unintended consequences on robot behavior. With over 5 million units actively deployed, iRobot uses AWS RoboMaker in their continuous integration pipeline to easily scale and run hundreds of tests and simulation for each software release candidate. Let's see how this works in AWS. First, we will open up the AWS RoboMaker console. For this quick demo, I'll use a development environment in the cloud. The robot application we're using today is our robot monitoring sample application, which you can find in the AWS Robotics GitHub organization. So let's say our customers expect our robot to be able to navigate autonomously in multiple different room layouts and locations. You'll notice in this JSON document, we have defined a set of environment variables for each scenario, testing for the behavior that our customers are expecting. Once these scenarios are defined, we can go ahead and merge our code changes into an integration branch. A webhook has been configured in GitHub with AWS Code Pipeline, a managed continuous delivery service to start a new job. The ROS application will be built and bundled using Colcon in AWS Code Build, a managed build service. Once complete, a batch of AWS RoboMaker simulation jobs are triggered and monitored through a set of compute functions running in AWS Lambda. Each simulation job runs a single scenario, and when complete, automatically self-terminates with the test results tagged to the simulation job. Let's open one of the simulation jobs. You can see that the robot is navigating to multiple goals. Once complete, the job will tag the test results and self-terminate. Finally, the results for all of the tests are analyzed and the code integration is either passed or failed. To learn more about how your business could use AWS RoboMaker, check out our website at aws.amazon.com/robomaker. There, you'll find links to our technical blogs that describe many use cases, like automated testing and fleet simulation. Finally, get hands-on at robomakerworkshops.com. Thanks for watching.